Alright guys, welcome back, and here we're looking at question 2 that involves a fractional function. So f of x here is actually a fractional function where we have a numerator and a denominator, and g of x is a simple function that we've looked at before. So question 2 says, given f of x is equal to 5x plus 8 over x minus 2 and g of x is equal to 6x minus 3, determine the following. Now the thing about f of x is that it has two cases where x is, which means if this is the mother kangaroo, then it has two pouches, and if it's a baby kangaroo, it's a pretty big baby. So let's take a look at answering the question here, one step at a time. So let's take a look at the solution to question 2. Now, part 1 says, determine f of g of x in its simplest form. So we're going to go ahead and attempt to determine the composite function f of g of x. Now, in part 1, f of g of x would mean that the mother kangaroo is f of x. So I'm going to write that function first, and that is simply going to be equal to 5x plus 8 over x minus 2 based on the question. And the baby kangaroo here is g of x, which is equal to 6x minus 3. And again, the baby kangaroo is going to jump wherever x is. And in this particular case, you have two instances of x. So it's going to jump here, and it's also going to jump there. So we have a case where we have two pouches, so to speak. So therefore, f of g of x is going to be equal to 5, and instead of putting by the x now, we're putting by 6x minus 3, and that has to be in bracket, and the plus 8 comes back over 6x minus 3 also goes there, and then we put back the minus 2. So what we're going to do here is we're going to actually go ahead and expand and simplify. So this is going to be now 5 times 6x. That's going to be equal to 30x. 5 times minus 3, that is minus 15, plus 8 all over 6x. And you owe 3 and you owe 2, that means you owe 5. So I'm just going to go ahead and finish up this part of the question. And it's already finished. So we're going to simply note that we have 30x, and you have $8 at home, and you owe 15. The person is coming for it, you have to give them the 8, and you still owe them 7. So that would be your answer there, and that is exactly what f of g of x is equal to. And that will be the final answer for part 1. But I want to bring something to your attention before we move on from here. Now, in here, for the final step here, we can't simplify any further. But what if you had a case like this? What if you had a case where you had 30x minus 15 over 6x minus 3? Now, and you got that for your final step. Now, that wouldn't be the simplified form, to be honest with you, because that can be simplified further. And if you look at each of the terms, 30x, minus 15, 6x, and minus 3, 3 can come out of each of those terms. So if you focus on the top, okay, it's not a situation where you're going to factorize completely, but factorize what is going to come out in terms of highest common factor for both top and bottom. And in this particular case, is 3. So if I had this, it would be the final answer, because this could have been simplified further. Unlike this, where this cannot be simplified any further, because 30x minus 7 over 6x minus 5, you're stuck there, and that would be your final answer for part 1. But in this particular case, if you look at the numerator, 30x minus 15, I could have factored out 3, leaving 10x here and 5. And why 3? Why did I choose 3 and not, let's say, for example, 5? The reason why I factor out 3 is because 3 is also the factor of 6x minus 3 as well. So if I factor out 3 down here, I have 2x minus 1. And then, in essence, the 3 can be cancelled because it's multiplication between the 3 and the brackets. Right? So the final answer in this particular case would be 10x minus 5 over 2x minus 1. So when I get to the final step, always check to see if you can simplify by a factorization as well to get the simplified form. Always check to see that. But in this particular case, we cannot factorize, we cannot simplify any further, so we'd have to stop there. So that will be the answer to part 1 of the question. So I'm just going to go ahead and tick this off because we found that. Now let's move on to part 2. Now, part 2, they're asking us to determine g of f of x as a single fraction. So watch these things here. Determine f of g of x as a single fraction. Now that sounds interesting, so let's take a look at that. So g of f of x would imply that the mother kangaroo is g of x, and g of x is simply 6x minus 3, and the baby kangaroo is f of x. In this particular case, this baby is a massive one, and this is going to jump wherever the pouch is, which means wherever x is in the mother function or the mother kangaroo. So all of this here is going to go wherever x is. So we're replacing x with that massive function, which is a fraction. So therefore, g of f of x is simply going to be equal to 6, open bracket, 5x plus 8 divided by x minus 2, close bracket, and then we put back the minus 3. So I have to be extremely careful with this one now, because I've seen over the years students make many errors with this step. Now we have to bear in mind that in order to write it as a single fraction, we have to do some tidying up with this region first. Now remember that the 6 can be written in fraction form. 6 is the same as 6 over 1. Now what we're actually doing is multiplying numerators by numerators. So in this particular case, the numerator is 5x plus 8, and denominators by denominators. And in this particular case, the denominator is x minus 1, and then this 3 comes back by itself. So what we're going to do is proceed in attempting to get this function, this composite function written as a single fraction. So far this is what we have. We have 6, open bracket, 5x plus 8 over 1, open bracket, x minus 2, and then minus 3. So what we're going to do here, 6 times 5x, that is 30x, 6 times 8, that is 48, and 1 times that is simply x minus 2 minus 3. And at this point, I'm just going to emphasize that 3 is the same as 3 over 1. Now, in order for me to write as a single fraction, I need to get both fractions having the same denominator. In this particular case here, I have 1 as a denominator. So to deal with that, I'm simply going to do this to allow, to try to get the same denominator on the board. So this is x minus 2. So what I'm going to do is multiply here by x minus 2, and anything I do to the denominator, I have to do to the numerator as well. So what I'm going to end up with here, don't expand here because you're going to make an error, because this minus actually belongs in front of the 3, and you're going to forget that. So what you want to do is establish that you have the same denominators now, because 1 times x minus 2 is going to give you x minus 2. So we're going to have the same denominators. So we put everything over x minus 2, and then now we can proceed to expand and simplify. Right now we have it as a single fraction. We just simply need to expand and simplify. So we're going to have 30x plus 48, and minus 3 times x is minus 3x, and minus 3 times negative 2 is positive 6, all over x minus 2. So we group the like terms. So 30x minus 3x, that is 27x. 48 plus 6, that is 54 over x minus 2. So therefore, g of f of x is equal to 27x plus 54 over x minus 2. And that will be the answer to part 2 of the question, which is asking us to write g of x as a single fraction. Now part 3 is very, very simple, and we can get that done very quickly, because if we have g of f of x, then finding g of f of 1 is no problem. So let's just get that done. So for part 3, g of f of 1, so seeing that since g of f of x equals 27x plus 54 over x minus 2, then g of f of 1 simply means replacing x with 1. So it will be 27 times 1 plus 54 over 1 minus 2. That's 27 plus 54 over negative 1. And that is equal to 27 plus 54, that is 81 over negative 1, which is simply negative 81. And that is what g of f of 1 would be equal to. So I hope you guys found this video insightful. We'll come back with a third example in a bit. So I hope you guys found this video insightful, and I'll see you guys on the next video.